Guys. Today I'd like to demonstrate for you one of the more difficult examples from the course. In fact, in chapter 9, homework number 4, which is using multiple regression to model seasonality in a time series, which means data collected over time, either quarterly or monthly or yearly, etc., or even by second. So we're going to go to this example. Wrong one. Go to this one. There we go. Here's the example. Believe it or not, I tried this about 4 times. Okay, here goes. So we have some data. I'll show it to you in a second, but we want to use multiple regression and categorical variables, which is something I have to discuss separately, to incorporate seasonality for forecasting consumption. December is the reference month. So basically, we have to come up with numbers that weight each of these different months and, in fact, month number to predict consumption. First number is simply the intercept. Has no variable attached to it. So the example data is here. Open, and you can see, let's open it in Excel. Let's be done in Excel. Open up the Excel file, and you can see that we have here month and year. So it's 3 years worth of data, monthly data. This is the consumption, the Y variable. And it's basically, we're assuming that it changes over time. As months proceed, then the data is going either up or down in some straight line. But superimposed upon that straight line is some seasonality, meaning that it might go up for a couple of months and start going down for a quarter and going up again, like kind of like a S-shaped. Basically, we're saying that January in 1 year has something to do with January of the next year and January of the third year, meaning that January has some unique characteristic, and likewise February, March, April, etc. Now, we can't put down like month January, we'll put down here month, and because think of a smaller example. Let's say you want to model race having an impact on something, on income or something else, or weight. You can't put down black equals 1, white equals 2, and Asian equals 3, because it's arbitrary. It's not like at the 3. And when we're talking about age, 10 years is twice as big as 5 years in a ratio scale. But 3 is not 3 times bigger than 1. It's just an arbitrary number that we use to represent the name. So the trick to do so is to put in, let's see if I can still find it. I did this in a previous example, so instead of typing it again, let me just copy it. This is what it's going to look like at the end. So for step number 1 is you type in January, February, March, etc. into those fields, paste. Likewise, in column O, you put down the month. You'll see we need this in order to figure out the categorical variables. So you put down January, February, March, etc. And again, I don't have to type it because I did it before, prepared it. Just forgot to share the screen. That's why I have to do it again. Let's copy all this. Copy. And we don't need this anymore. Paste. And this should match up December with December. Okay. Now, the real Excel trick is to use the statement that the book actually suggests, or the homework when you say help me solve it or show me an example. It's this statement here, which we can get from the other example. It's right here. If $02 if O2 is equal to D1, then make that a 1. If not, make it a 0. So if we copy that, copy, and we put it into R, it becomes a 1. So January, in fact, does match up with this. And if you copy this over, it should be all, the rest should be 0. So January is symbolized by a 1 in this column and zeros every place else. But if you pull this down, you create February is symbolized not by a 2 or a 3, it's symbolized by 0, 1, 0, 0, 0, in particular with a 1 in the February column, and March, etc. And finally, remember, there's only, I should point out to you, when you have 3 categories, there's only 2 variables. If there's 2 categories, there's 1 variable, like 0 and 1. If there's 3 categories, it's two columns. When there's 12 categories, this is strange. It should have been a capital O. I'm surprised that it didn't cause a problem. Change it to a capital O. I don't think it changes anything. We need 11 columns for the 12 months. So again, January is like this. And finally, December, which is not really one of these columns, is symbolized by all zeros. It's called the reference category. Now, once we have this, we can now perform the multiple regression. You go into data analysis, regression. And again, I told you I just did this once before. So first of all, you pull down column B from B1 to B37. Likewise, you pull in all the other variables. The X variables are column C through M. So it's C1 through N37. But we have labels at the beginning of every column. You hit OK, and you get, in a separate version, you get the regression coefficients, the intercept, the number, front of month, etc. And these are the numbers you're going to be placing into the boxes that represent the question. Notice that the R squared is very high, meaning that we have a great fit. Notice that the p-values are all very small, certainly lower than, really small, too small, in fact, all lower than 0.05. This means 0.000, 19 zeros and a 317. This means 0.02. This is 5 zeros and, 0.0000918. That's how you read this. Anyway, the question itself asked us to fill in these coefficients. That's all it's going to be, the rest of the example. And going to the Excel, we're going to look at this. So it's 22.97 minus 046. So 22 point, let's see if we can just copy this. I doubt it, but copy, place it here. See that. Paste. No, I think you have to do the following in the Excel. You have to get into the box. And 22.97. Copy. Now the paste should work. Where's my paste? Oh, I give up. 22.97. The number in front of month, the coefficient in front of month is minus 0.046. The number in front of January is minus 4.6. The number in front of February is gotta be a faster way, but minus 8.17. Minus 8.17. Number front to March. I guess we'll just plow through this. March is minus 9.86. April, minus 10.98. May, apologize for this, minus 14.43. Imagine getting it wrong after all this. June, minus 14.55. July, minus 11.08. August, minus 12.25. September, minus 13.58. And October, minus 13.27. And finally, November, which is minus 6.97. Drum roll, please. Check into, oh my God, I got it right. Similar question. So again, before we leave this question, how would you use this question? So for example, they're all significant, so we can leave all the variables in the variable. Let's say we want to predict consumption for month 37. Remember that we have data for 36 months. Let's say you want to go month 37. So you plug a 37 into this, and the 37th month will be January. So that means January is a 1, and everything else is a 0. So this part of the calculation just disappears. And it's minus 4.6 times 1 times 37 plus 37 times minus 0.046 plus 22.97. That number is our prediction, taking into account the seasonality of January. Let's say we're making a prediction for December. Well, December is they're all zeros. Remember, that's how we just depicted December. So everything disappears, but it's going to be, I think December might be, I don't know, the 47th, the 48th month. It'll be 48 times this plus that. And that will be your prediction. Okay, let's hope this time, which is like the 4th or 5th time I'm doing this, works.